I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover an overview of the threat prioritization process. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training. This training will cover an overview of threat prioritization. When we think about how cybersecurity is done in the context of product development, it tends to be in the same way that we think about a one-man band. They're responsible for bringing their own instruments, playing the music, and dealing with everything else related to the activity. The classic example of this is penetration testing. You can penetration test anything. You don't need input from anyone else. You just need the system to be evaluated. When you're done, you produce a report. Now consider threat modeling. In threat modeling, you look at the system, conduct an analysis, and again, produce a report. A report which typically looks nothing like the report that we get from penetration testing. And fuzz testing is another version of this same story. In our example here, with our three one-man bands, if we were to have them play simultaneously, the result would probably not be pleasing to the ear. What we want is more like a symphony orchestra, where the products of each of the performers comes together into something greater than the sum of the parts. That's the point of having a threat prioritization process applied uniformly across multiple activities. We want a methodology that produces consistent output, not requiring special handling for every cybersecurity activity. It's very useful to have a process that can handle the prioritization of threats coming from multiple sources. So let's take a moment to consider what those sources are. For simplicity's sake, we'll address the threat sources in AVCDL lifecycle sequence. First, we have attack surface analysis. It might not seem obvious that we'd include the attack surface analysis in this list, but not every identified issue in the attack surface analysis can go directly into the issue tracking system without review. At the other end of the spectrum, we have threat modeling. The expectation is that threat modeling generates threat candidates which need further review, as the issues that come out of that activity need to be reviewed in the system context, which is what the threat prioritization process does. Next is deprecated functions. Not all deprecated functions currently in use are going to need to be replaced in order to ensure the level of cybersecurity that we'd like to have. So we need to put them through this process. More obvious sources are static analysis, dynamic analysis, fuzz testing, and penetration testing. Keep in mind with this one that just because you can break it doesn't necessarily mean that it needs to be fixed. We need to consider these issues in the greater system context. Finally, we have incident response. As with attack surface analysis, incident response doesn't come immediately to mind. However, with incident response, once we've replicated the problem, we have a threat, and we need to determine how it impacts the system. As with penetration testing, just because it's a valid issue doesn't mean it needs to be addressed. We need to take issues and give them context, and that's part of the process we go through in the threat prioritization process. The only exception to this is an incident response, where the threat prioritization process takes place in the middle of the incident response process. Refer to the incident response material for additional detail on this. Now let's look at the threat prioritization process workflow itself. Here we have the main part of the threat prioritization process workflow. It's comprised of three activities. These are threat candidate ranking, ranked threat candidate risking, and finally, threat candidate slicing. Now let's turn our attention to each of these activities that go into the threat prioritization process. Our first activity is that of threat candidate ranking. The goal of this activity is to establish the likelihood of each of the threat candidates. The security SME takes the triage threat candidates and conducts a ranking on them, producing a list of ranked threat candidates. Any candidates which are determined to be invalid are dismissed, and their source tracker is updated accordingly. A few things to consider here. We want to focus on the worst case outcome if the threat is realized. Second, when performing this activity, we seek to use a standard rubric so that we have consistency and reproducibility. Our second activity is that of threat candidate risking. The goal of this activity is to establish the impact of each of the threat candidates. The risk SME takes the ranked threat candidates and applies a risk rubric to them. This yields a list of ranked risk threat candidates, and a ranked risk threat report is generated. Here the focus is at the system level, because it's at this level that risk determination can be made. Specifically, the risk SME is looking at how the threat candidates impact the system based on the worst-case projection provided in the ranked threat candidates. As with the candidate ranking activity, we want to, where possible, use a standard rubric for the determination of the impact that the threat candidate has. Our third activity is threat candidate slicing. The goal of this activity is to establish which threat candidates are uncontrolled. The security SME takes the ranked risk threat candidates and performs a slicing operation on them, identifying the uncontrolled threats, which are then sent to the issue tracking system. Any threats deemed to be controlled are dismissed and their source tracker is updated. Finally, a threat report is generated. Determination of controlled versus uncontrolled threats is based on an approved risk appetite, how much risk the organization is willing to tolerate in terms of a threat. A final note here is that it's important not to game the results. Don't modify the risk appetite threshold just to keep the number of identified uncontrolled threats low. If a threat is determined to be uncontrolled, then it should be addressed. Typically, when we talk about risk in the context of safety-critical cyber-physical systems, we're talking about safety risk. But in reality, there are multiple risk domains that we need to consider. The first and most obvious risk domain is that of safety. This is unsurprising given that we're dealing with safety-critical cyber-physical systems. Second is finance, where issues impact individuals or the system's manufacturer. Third, we have operational risk, where we may have interference in the operation of the system itself. Note that this domain deals with impacts which are not safety-related. Finally, we have privacy. This may be either related to the identification and tracking of the system itself or of individuals who are either operating or proximate to the system. If we have multiple risk domains, this poses a problem as the workflow, as presented, doesn't seem to support this situation. Keep in mind that each risk domain has its own basis for assigning impact values. In order to address this, we'll need to take our ranked threat candidates feeding into the risking and slicing activities and instead apply them on a per domain basis. This is going to yield a list of uncontrolled threats for each domain. We'll then need to add an additional activity that will perform a consolidation of all the uncontrolled threats. Let's look at that activity. In the consolidation activity, the security SME takes the uncontrolled threats from each of the risk domains under consideration and consolidates them into a consolidated uncontrolled threat list, which is then fed into the issue tracking system. Additionally, a consolidated threat report is generated. Because you are considering all risk domains, you'll have cases where multiple risk domains call out the same threat as uncontrolled. Because of this, it's important to preserve traceability so that you can ensure and verify that each of the threats has been treated as appropriate for the risk domain it impacts. That covers our overview of the threat prioritization process. Let's look at a summary. When performing threat prioritization, first determine the likelihood of each of the candidates. Next, determine the impact. Third, identify the uncontrolled threats. And finally, merge any multiple risk domain information. For more information and to get a more in-depth set of references, the Threat Prioritization Plan secondary document is available in the AVCDL GitHub repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. With this training complete, if you've completed the other trainings covering the threat prioritization process activities, you can proceed to attack surface analysis, threat modeling, penetration testing, and vulnerability identification. Additionally, if you've completed secure coding and its prerequisites, you can proceed to static analysis, dynamic analysis, fuzz testing, and secure code review. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL GitHub repository.